Hey there, Seahawks. It's Miss Adams, and in this video, we're going to take a look at basics of trend lines. All right, so when we see a relationship in a scatter plot, we can use a line to summarize the relationship in the data. We can also use the line to make predictions in the data. This process is called linear regression. So fitting a line to the data. There are more advanced ways to fit a line to the data, and we will get into those later on into this unit. But in general, we want a line that goes through the middle of most of the points. All right, so which line out of these options, A, B, and C, graphs this data that we have with the blue dots? Okay, so the one that matches that the most is line A. All right, using an equation for the lines of fit. Once we fit a line to the data, we find its equation and then we use the equation to make predictions. So the percent of adults who smoke recorded every year, every few years since 1967 suggests a negative linear association with no outliers. A line was fit to the data to model the relationship. So years since 1967 is on my x-axis, and then the percent of adults who smoke is along my y-axis. And I can see that there's a negative trend. I can see that they already went and gave me a line of best fit. So they want me to find the slope. They want me to write the equation and then use the equation to make a prediction. So find the slope. The line goes through 0, 40, and 10, 35. Okay, so I just picked 2 points that are on my line that are nice, like axes, and I can find the exact ordered pair that that line goes through. And then you can find the slope doing y2 minus y1 over x2 minus x1, just like you learned in Algebra 1. So 35 minus 40 is negative 5. 10 minus 0 is 10. That simplifies to negative 1/2. Or you can look at the graph and do rise over run. So I went down 1 over 2 units. So my slope was negative 1 over 2. Find the y-intercept. So that's where it's crossing the y-axis. We can see that the line passes through 0, 40. When x is 0, y is 40. So my y-intercept is 40. And then write an equation in y equals mx plus b form. So we are actually going to change up that order when we get into like a bit more advanced linear regression, but we'll just keep it like how you're used to for Algebra 1. So y equals negative 1/2 x plus 40. Based on the equation, estimate what percent of adults smoked in 1997. Okay, well, this was years since 1967, so 1997 would be 30 years since 1967, so I'm going to plug 30 in for x. So I'm going to have y equals negative 1/2 times 30 plus 40. Negative 1/2 times 30 is negative 15. Negative 15 plus 40 is 25, and then don't forget this is 25 adults. All right. So I guess it's really 25% of adults. All right, the next one. Jacob distributed a survey to his fellow students asking them how many hours they'd spent playing a sport in the past day. He also asked them to rate their mood on a scale of 0 to 10, with 10 being the happiest. A line was fit to the data to model the relationship. Which of these linear equations best describes the given model? Okay, so I can tell from the scatter plot that there is a positive relationship, so the slope needs to be positive. I can also tell that it's crossing the y-axis at 5, so the y-intercept should be 5. Okay, so I'm looking for the one that has a y-intercept of 5 and a positive slope, which is the second option, y equals 1.5x plus 5. Based on the equation, estimate the mood rating for a student who spent 2.5 hours playing sports. So I'm going to take that equation and I'm going to plug 2.5 in for x. 1.5 times 2.5 is 3.75 plus 5 gives me 8. So they'd have a mood rating of 8.75. Okay, and you can also kind of estimate that if you look at the scatter plot and you go up at 2.5 and over, you'd be pretty close to what we estimated, 8.75. All right, go Seahawks.